Hi everybody, welcome to another YouTube video. Thanks for coming back. Today we are in between Durham and Newcastle. I'm going to show you this solar PV, battery storage and EV job that we've just completed on this new build estate. I'm going to take you through the app and lots of other cool things. So let's get into the video now and I'll show you these panels to start with. Okay, so since we're outside, let's start with the panels. So you can see here, the angle's a bit tight, but you can see here we've got 14 per light 435 watt panels, which is just over 6 kilowatt peak, so a 6.09 kilowatt peak of energy that is up on that roof. We've got the solar skirt bird protection wrapped around them as well to stop the pigeons nesting under there, and it also gives it a really nice finish on the system. It's an all black panel as well, so it means that it just looks really sleek and really modern, which when you're buying a new build property you want it to look like. So the power from these panels heads down through the house into the garage where we've got the MyEnergi Libbi hybrid battery and inverter system, and that means that everything is contained within the MyEnergi app. The customer's got one app where they can see what the solar's doing, what the battery's doing and what the EV's doing, and control all three of those elements within that one app. So we'll get into that in a little bit, but just take a minute to look at how nice those panels look on that new build roof, and hopefully we'll be back to get more of these on this new build estate. Okay, so now we've had a look at the panels, let's head inside to the garage and have a look at where the MyEnergi battery is and all the gubbins there. This is the really interesting bit. Okay, so we've made it into the garage now, and you can see this is where our Libby system is. So I'm going to go through all of these components step by step so you can kind of see what makes this system up. So let's start right at the beginning, which most of you will have, or all of you will have to be fair, is consumer unit. So this is a new consumer unit that the customer has installed, who's also an electrician. A new one installed, so we've got a circuit here for the Liby Controller, which I'll show you in a minute, and then another circuit for the Libby solar PV and battery storage unit, and then another one for the EV charger. So they're built into this main house consumer unit, keeps it all tidy. We haven't got multiple consumer units. It's it's nice and tidy in there. So out of there, if we look at the solar and battery system to start with, it comes out of that consumer unit into our trunking, down to our AC isolator. So we've got to provide a means of AC isolation, so basically isolating that cable from the consumer unit into the battery / solar inverter. So it comes from there down into the generation meter. So this is an MCS requirement, so that generation meter will track all of the units of electricity that the solar PV system generates and also discharges. It's a net meter, so it's a bidirectional meter, which means it'll track all the power that the system may buy in because of a cheap tariff, and all the kilowatt hours that the system exports back into the house, and then it'll give a net figure so that it knows what's left is what the solar has generated. These generation meters, I would love to see them go. They're not really needed nowadays, but it's still an MCS requirement for us to include them. So when we've got a hybrid system like this, they need to be a bidirectional system so that you can see what the true solar generation is. So out of that bidirectional generation meter, it comes out into the trunking and then into the Libby battery. So what I'll do is I'll just unscrew this and then we'll go through the Libby itself. But you can see it's a real nice looking unit, like an all-in-one system, so you haven't got all the battery cables dangling around. And since the PAS 63100 document came out, it's basically told us that as best practice all the battery cables should be built within a metal container, mainly so kids can't access them, and they can't be tampered with without a tool or without a professional being there. So that's why this is a really nice unit, because everything is self-contained within this metal cabinet. So if we have a little look at this, we've got this HO7 flex that comes into this big AC plug that comes down, and that goes into the AC isolator / generation meter over at that far side. Whilst we're in this little area, we'll have a look at some of these other bits. We've got a comms cable here which comes from our Liby controller, which I'll show you in a minute, and then we've got some PV strings. So those panels up on the roof, they feed down into this via some surge protection and some isolators, which I'll show you in a minute, but they feed directly into this inverter. So this is the inverter part here, and that deals with the solar side and the battery side, and basically will either discharge power back into the house because there's a demand, or allow the power to go into the batteries to be stored because they're generating more power than is needed, or there is a cheap tariff overnight. So that is that. We'll have a little look at the other parts on this board now, and I'll tell you how that kind of works with those connections we've just seen. So let's have a look at the DC side of the system. So we've just been over how the AC side of the system goes together through the isolators and meter and into the inverter. Let's have a look at the DC side. So let's start with the cable coming from the panel. So this is the cable here. So this is a Doncaster Cables PV Ultra, and this has 4 solar PV cores built within it. That brings that DC power down from the panels down into this and into this surge protection box. So here we've got a surge protection device for string 1 and string 2. We can see that we've got all the green windows here, which means that they're all healthy and active. There's none that have blown because there's been a surge device. So if you have these surge protection devices on your system at home or your business, then just check that the windows are all green. That means that they're all still active and still protecting as best they can the installation. That's all built in that little box. And then out of there we've got our 2 string isolators. So either one of these isolates half the panel. So we've got 14 panels, so we've got 7 panels on this one and 7 panels on this one here. So that means that if we have a problem on one set of panels, say the top set or the bottom set, we can isolate those and allow the system to work on 7 panels. There's a lot of chat about, you know, removing DC isolators from systems because they are an extra failure point. But for me, I think having a DC isolator allows for better maintenance, and also when we have to maybe change this inverter or do any work on the inverter and we need to disconnect those DC strings, if we don't have this DC isolator, then there's no way to make these safe to work on. Inside the Libby there is a DC isolator. So we've got a DC isolator here, so we can isolate the DC going into the Libby's inverter, but it won't isolate these plugs here. So that's why we still want these DC isolators before that, so that we know we can turn those off and these cables are dead and therefore safe for us to work on. So that's why we like to fit the DC isolators. If we have a look now at the Liby Controller, so we had that additional circuit in the consumer unit that comes through. We always fit a little switch fuse unit here, switch fuse with a 3 amp fuse in, and that just means that this is fused down to 3 amps as per the manual, comes in. That is really the brain of the system. So what this does is it looks at all the information coming from the CT clamps. So there's one on the main grid supply, and that's actually it on this system because the Libby has control of the solar, so it knows how much the solar's generating. But if there was an external solar inverter, maybe like an old feed-in tariff inverter, and this was an additional system to the feed-in tariff system, then we could fit an additional CT clamp, which is a little clamp, we'll have a look in the meter box in a minute, a little clamp that goes around a cable and monitors the current going through that cable. That is then configured onto the device, and you then instruct that device to look at that current and identify what that current is coming from. So we would put that CT clamp around that feed-in tariff inverter, and we would go, okay, Liby Controller, there is an additional CT clamp input. This, by the way, is an additional solar PV system on the installation, and then it can add that current that it sees coming from that feed-in tariff registered inverter onto its total solar that it's got at the property. So there'll be the solar on here and the solar from the feed-in tariff registered inverter, and it can add all that together so it can give you a total amount. That doesn't affect the feed-in tariff. It's good because you can see on one app everything that's happening in the property. But we haven't got that here. This is the only solar PV system, so it's a nice simple install with basically just one CT clamp on the main incoming supply. This also connects to the internet and therefore connects this to the internet. So there's a comms cable that comes from here into here, which is this grey one just on the side, and that is how these two talk to each other. The internet to here is all on Wi-Fi, but you can hardwire it if you want, but this was easier to do on the Wi-Fi connection. It was a nice solid connection as well. So that is all good with that. Okay, so we've had a little look at all of the external parts of the Libby. So the isolators, the surge protection, the cabling, the controller. Let's actually chat about the Libby itself. Because a lot of you might not have seen anything to do with the Libby, and other people might be considering the Libby. We're doing quite a lot of these at the minute because they are just a really good solid unit, and the app is fantastic, which again I'll show you in the future. So I'll just pop this cover back on, and then what we'll do is I'll show you the battery capacity, what we've got installed here, and what the system is able to charge and discharge at. So like I say, I really like the Libby because it's aesthetically pleasing. You're spending some money on the system. We don't want it to look like a bowl of spaghetti. We want it to be nice, clean, everything in trunking, and it kind of fits how we like to leave systems. We like to leave people impressed with the level of detail and the level of thought that's gone into where cables run, where isolators are positioned, and also thinking in the future as to how these systems might adapt over the next 10-15 years. So let's start with the inverter. So this is a 5 kilowatt Libby inverter. So that has the ability to have a load of solar PV into it. So from memory, it's about 3.4 kilowatts of solar PV per string. So 6.8 over the total system. That's how we can get so much solar onto this, and that, like I say, plugs directly into the Libby. We've then got the ability to discharge and charge the batteries, or discharge into the house at 5 kilowatts. So we can, this is kind of the bottleneck of the system. So we've got more than 5 kilowatts of solar PV feeding in. We've got just over 6, and we've got 10 kilowatt hours here of battery storage. So what we can do is we can pull from the grid during a low tariff period, which this customer does, up to 5 kilowatts and push that into the batteries. So with 10 kilowatt hours of storage, we're charging that up in 2 hours. Or we can divert the solar PV that comes directly into this into the batteries as well. But this is kind of the bottleneck of the system. We can only discharge into the house 5 kilowatts, which is a really good amount and is kind of what's fast becoming the industry standard. Or we can discharge the batteries at 5 and put that in, or a mixture of the two. We could have some solar and some battery power discharged into the property at a limit of 5 kilowatts to supply up to 5 kilowatts of load in the property. This has got the ability to have some backup loads on as well. So if you did have some socket circuit or a lighting circuit or a mixture of the two that you wanted to supply in the event of a power cut, then we can do that through the Libby as well. We haven't got that feature on this system because it wasn't important to the customer, but that is there for if you want it in the future. There's more wiring and more cost to doing that because you have to have a separate little board that is just designed to be supplied in the event of a power cut. We've got an earth rod to put in, so it does increase the cost, but you don't have to do everything all at once. You could have this installed, and if the grid in your area becomes unreliable, then that can be an added extra in the future that you add to the system. The hardware is there, it's just a little bit of moving around of circuits and a little bit more electrical work, but we don't have to replace this full unit to allow you to do that. So like I say, 5 kilowatt inverter. If for whatever reason you don't want a 5 kilowatt inverter or you're not allowed one through the DNO process, then you can get a 3.6 version of this. So there's two options, a 3.6 or a 5. You can't downrate the 5 kilowatt to 3.6, but you can set export limits and DNO limits on the system. So if they won't give you the full 5 kilowatt export, then we can set within the controller a DNO limit of whatever it is that they want. So, but this inverter will always have the capacity to discharge at 5 kilowatts. Looking down here, we've got two modules. Like I say, they're 5 kilowatt hours each. So we've got 10 kilowatt hours of capacity here, and we can extend this up to 20 kilowatt hours. So we could have just next to this position here where these weights are, we could have another 2 batteries. So we could have another 1 or another 2 and bring this up to 20 kilowatt hours of stored capacity. We've left some space here so that if the customer ever did want to add 1 or 2 more batteries, then they could sit there quite easily and they just plug into the rest of the unit. So that's a nice, easy install for the future. A lot of what we do as a company is trying to future plan and have good conversations with the customer about what might happen over the next 10 years. They've just bought this new build property and so they're getting used to living in this place. And so for them to know exactly what they want when they haven't even lived in the property is quite difficult. So that's why we like systems that are easy to expand on, easy to tweak, and that is definitely what the Libby is. So that's why we've chosen that for this property. So yeah, got the space there to add more battery capacity, and like I said, that takes up to 20 kilowatt hours, which would take longer to charge. But if the customer did want a backup system, then you can set a retention so that you might want one of these battery modules to just be sat there fully charged all the time in case you have a power cut. But there's so many different options, but you can take this to 20 kilowatt hours. So that is the Libby. We've got our documentation here as well. So this is what you should get with all your systems. We've got a start-stop procedure on how to isolate the Libby from the supply and how to reset it. We've also got a schematic here showing any electrician or anyone that's interested how all of this is connected in and where all the clamps and everything are. So that is all of that. We've also obviously got all the manuals and everything in here, and the customer will also receive a handover pack from us which has the same information over an email, but also about all the warranties, maintenance and everything else. So that's what you should get, as well as an MCS certificate. So you should get all of that from your provider, and you certainly would get all that from us as an installer. Okay, so we've had a little look at the MyEnergi Libby. So now let's have a look at MyEnergi's oldest product. I think it will be, but it'll be between that and the Eddy. We're gonna have a look at the Zappy now, and that is their kind of rule breaking in a positive way Zappy EV charger, which basically set the whole industry on this path of looking at diverting solar PV power into your car. It wasn't really a thing before the Zappy, so it was pioneering in that sense. So what we've got in here, we've got a double pole RCBO in the board. That comes out into this cable here and comes up and over the garage and then through into the back of the Zappy, which we're going to have a look at in a minute. We've done that to basically hide the cabling as much as we can, so we didn't have any cabling on the outside of the property. It makes it nice and smart, but it's also hidden in here because it's coming up and over the top of the garage, sort of under the garage ceiling. So that then wirelessly talks to the Liby Controller, which links them together and puts everything on the app, which we'll run through the app shortly. So let's go and have a little look at the MyEnergi Zappy. Okay, so the Zappy is actually just around the side of the house, so it's not on the front of the house where it can be seen quite clearly. It's just tucked away behind this drain pipe and just around there, all the meter boxes and everything else like that. So it's tucked away from view, but the cable is long enough to reach onto the driveway and plug into the car. So this is the black tethered version, which basically just means that the charger has the cable built on. You can get an untethered version, which would be where this holster is here, there'll be a socket. So you'd have then your own type 2 lead like this that you would plug into here, which would get the power from the Zappy, and then you would plug that into the car. So it is more economical to buy a tethered Zappy because you basically get a lead with it, this tethered lead, for about 60 quid, which you can't buy for that if you tried to buy a standalone lead. The Zappy has a really nice display, so this is actively showing us what the solar is doing, what the house is doing, and what the grid is doing. And I can happy to report that the grid is we're not importing from the grid and we're not exporting to the grid. Everything is going into that battery or being used by the house. And it also shows you how much energy was last put into the vehicle. So we've got 57 kilowatt hours that was put into this vehicle during the last charging session. We're on Eco Plus mode, which is the greenest mode that you can select. We'll have a little look on the app shortly to see what that setting is, and we can run through that. But there's 3 modes: Fast, Eco and Eco Plus. Fast is just a dumb charger that will just charge at 7 kilowatts or however much the car can take, up to 7 kilowatts. Eco Plus mode is it'll trickle charge the vehicle, but it'll start charging instantly. Eco Plus mode is basically where you set the threshold as to when the car starts charging based on the amount of energy that you are exporting to the grid. So we'll have a look at that when we get onto the app in a little more detail. There's a lot of videos out there about the Zappy, so I'm not going to go absolutely through every nut and bolt on it, but it's just a really solid charger that works well with the Libby, but also any other AC or DC coupled battery. Really works better on AC coupled systems, so basically where you've got a solar inverter and a separate battery, because it can monitor what the solar is doing and what the battery is doing. When it's a DC coupled system, it doesn't know what is happening on the solar and what is happening on the battery because it's all built into one unit. But there are things and ways within the Zappy that we can make the Zappy work with that sort of setup. So yeah, it's a really solid unit. The black is by far the most popular, and the tethered is by far the most popular as well. So yeah, really happy the customer decided to go with the Zappy. Okay, so we've had a look at all the hardware here, but let's be honest, you're not going to come in here and check this every single day. You're not going to go and look at the Zappy screen every single day. The app on pretty much all systems is one of the most important parts of the system, and MyEnergi's app is one of the best out there, and it has been since the Zappy and Eddy. So bringing the battery into that app directly is fantastic. So let's have a look at this home screen first. This is the app for this customer's property. So we've got these little bubbles or circles on the system. So if we start right at the top, we've got the house. So that typically that's just reduced its consumption because no one's in at the minute. But we saw just then that the house had a couple of 100 watts of usage. So that'll be things like the fridge freezer, the Wi-Fi. There we go, 300 watts. The fridge freezer, the Wi-Fi, TV on standby, things like that. Obviously, if the kettle went on, or electric heater went on, or anything like that, then we would see that spike in there. If we go to the right hand side, we've got a little pylon. That is the grid. That will show us if there's any import, any export, or anything happening with the grid. At the minute, there's nothing because the solar is generating 300 watts and the battery is charging up at 300 watts. So if we move down to the right again, we've got a little solar panel with a little sun peeking up behind it. That there is showing us how much the solar is producing in real time. All these values, MyEnergi actually round them to the nearest 100, so it might be slightly different. Like that's jumped to 400, so it might be 390 or 410 or something like that, but it still gives us a good representation as to what's happening. So you can see that solar is being fed into the system, and then that is being distributed between the house and the battery. If we keep going round, we've got the little car with the big plug on it. So that is the EV charger. So at the minute that's not in use, so that's why it's greyed out. But I'll go through all these individually in a minute. The next one is the Libby battery. So you can see there it's got a battery symbol, and it's got 0.2 kilowatts at the minute of charge. So you can see the arrow is going into that icon, so that means that the system is charging that battery. If the little arrows were pointing away from that, that would mean the battery is discharging. So let's start with the Libby. So if I press on the Libby, I'll explain the 100% in the middle in a minute. We can see a little bit more information as to what's been happening with this system today. So we can see the state of charge is 63%, so we're over half charged, and it is charging at the minute. If we scroll down, we've then got a little graph here. So we've got a pinky purpley line along the top, which is showing the state of charge. So that's tracking how close to 100% that is, and you can see how that's been working. So you can see there that it's been steadily declining all morning until this point now, where it's starting to tip back up because it's 20 to 1. So we're starting to get to the middle of the day. It's not very bright here today, but it is charging up. We've then got a green section, which is, you can see on the bars below, that is charge. So you can see today it's charged with 0.7 kilowatt hours of energy. The orange, which you can see is below the line before the green kicks in on the graph, that is discharge. So you can see there that overnight we basically discharged this system 1.4 kilowatt hours. So 1.4 kilowatt hours came out of this system. And then we've got the bottom, we've got the dotted line, which, like I said, is the state of charge. You can see that's at 63%. You can make that graph bigger. On there, it does put it into landscape, so we'll go back just because it's a little bit harder to show you on this video with that, but you can basically make that graph bigger, and you can see all this online as well on your laptop. So that is everything on the battery side of things. If we have a look at the house, so you can see here that this just basically shows you the spikes in the home. So you can see there we had a big spike at around 6 o'clock, which is probably the kettle going on or something like that, and a couple of others. But then after that, when everyone's gone to work, there's just this base consumption. You can see little spikes, which will be things like the fridge kicking in to keep the fridge cool, and the freezer, and all those other little bits. But we've got a fairly low base consumption here, but we have seen a consumption of 2.1 kilowatt hours. So that's not that that's all been purchased from the grid. That is just that the house has used 2.1 kilowatt hours no matter where it's come from. If we go around to the grid, this will show us a little bit more about what's been exported, what's been imported. So you can see here that we've got an imported amount today of 0.5 kilowatt hours and an exported amount of 0.8 kilowatt hours. So with a solar and battery system, the battery can't catch everything. Sunlight changes very fast, and so the battery has got to adjust to that. And sometimes when the battery adjusts to it, it then might over adjust because the sun's then gone down. So you'll always get what I call overspill. So we can see very little amounts there, but the house has imported very little amounts as well. And remember, we had that 2.1 kilowatt hours that the home has used, and basically for the use of that 2.1 kilowatt hours, they've only had to buy in 0.5 kilowatt hours. So it's yeah, doing pretty well. The 100% mark on this, now that we've touched on that import export and what's been used, that is a live representation as to how green this property is at the minute. So basically, how much is the house running on renewable energy, either from the battery, from the solar, from wind, because you can have wind on this, all these different things. And at the minute, the house is 100% green because everything is being supplied from the solar and is being distributed to the battery and everything. So you can see here, this is quite a good situation. So you can see we've got the grid, we're exporting to the grid at 0.1 kilowatts, and then the house just come back on. So what will happen is the battery will adjust and it'll wipe out that export, and it'll start charging up with that extra power. There we go. Just as I finished that, that's almost as if I planned it. So you can see there, that's the overspill that I'm talking about. So the battery's got to react quite quickly, and the app also only reports every few seconds. So it might have reacted quicker, but obviously the app has to refresh. So if we go down to the solar, this is just the solar PV generation. So you can see there that we've got an arc forming, which will be the case with all systems really. This is pretty much a south-facing system, pretty much done on south-facing. So we're going to hopefully have this nice arc. The smoother this arc is, the more they'll be generating, because we don't have these big dips, which is not doing bad, but it's a fairly dull day. So the peak of this system isn't going to be very high today. If we have a look at yesterday, hopefully yesterday was a brighter day. You can see this is a bit of a shaved arc, so we're coming up, but we didn't actually spike a generation till probably around, what's that going to be, around 10 o'clock, 9:30, 10 o'clock, and then suddenly it jumped up to just over 4 kilowatts. You can see that on the left axis there, we're just over 4 kilowatts. So it is very temperamental depending on the sunlight, as you can imagine, but this system generated yesterday in total, from start up to shut down, 25.5 kilowatt hours, which is usually more than what a house would need really. Let's have a little look at the Zappy. So the Zappy, I've not got permission to show you all of the charge settings on this because I've been granted access by the customer. But what we can see here is, let's have a look at yesterday, see when they last charged the vehicle. This is the thing with electric vehicles, if you don't do many miles, you don't often have to charge it that much. There we go, so we've got some info there now. This shows you how much energy was used by the Zappy to charge the vehicle up. So you can see that this is a block of time, and this was kind of Friday night into Saturday morning, and then Saturday night into Sunday morning, and we hit a peak of around 7 kilowatts, which is the Zappy's rating. So we can see there that there was 2 charging sessions, but they haven't actually had to charge the vehicle that much. So we do this week, there's been no charge, and yeah, that obviously this week includes today. So there's not been a huge amount of charge on the car, but the Zappy is there to do that. And if the customer wanted to, they could set the vehicle, the Zappy, to Eco Plus mode, which I said I would explain earlier on in the video. Eco Plus mode allows you to set a green level. So the thing to remember about electric vehicles is that they have to charge with a minimum of 1.4 kilowatts. So just keep that figure in your mind, 1,400 watts or 1.4 kilowatts. So what you can do in Zappy is you can set a minimum green level. So this is just on Eco Plus mode. So if you said 100% green level, I only want that car to charge from solar PV power. I don't want to buy any power to charge that vehicle. Then if you plug your car in, have 100% green level, and you set the Zappy to Eco Plus mode, which if you're the customer, you would do that, set on the Zappy or on your app, you'd have greater access than what I have on this customer's system. Then the car would sit there and not charge until you had a minimum of 1.4 kilowatts going back to the grid. There's a possibility that the car would not charge. You can set scheduled charges and kind of leave by points on the Zappy, so that if it hasn't charged, it makes sure it does start charging. If you say you have to have it charged up by Monday, you could leave it on charge all weekend, and then it would put into the vehicle whatever it wants, whatever it can from the solar power, and then it would the scheduled charge would then kick in to make sure you had enough on Monday. So you can do some safeguards, but certainly during the summertime, it's not uncommon for people with a system like this to be pumping power into their vehicle from the solar PV. So if you have a 100% green level, it'll only charge at a minimum of 1.4 kilowatts, and it'll only take that power from the surplus solar power available. If you had it set at 50%, then what would happen is the car would only start charging when you had 700 watts of surplus power. So it wouldn't start charging until it saw 700 watts going back to the grid. The other 700 watts to make us up to that 1.4 kilowatt threshold would then have to be purchased from the grid, discharged from the battery if you allow that, and made up to give us that 1.4 kilowatts. So that is the MyEnergi app. I think it's a pretty good one and a pretty simple one to look over. Okay, so this next little bit is a bit of a contentious issue because some installers are doing it and some aren't, and that is following the best practice guidance published in the PAS, the PAS 63100 document 2024, and it's really detailing where these systems can be installed and the requirements that the property needs to allow for these systems to be installed. Now, it's best practice guidance, and Oval as a company, we've taken this on board and are complying with it as closely as we can. Now, there are many installers, usually, to be honest, a lot of the installers that are the cheapest, that are just ignoring that this document has ever been published. Now, the PAS document has been put together by industry leaders, people that write the regs, people that enforce the regs, like manufacturers. Everybody that's like a big name in the industry has had a bit of an input in this, or most people have. And so it seems crazy to us as a company, and the reason why we've adopted it seems crazy that we would just ignore that has even happened. So I'll run you through a few things. Firstly, they recommend that batteries are fitted outside, and I appreciate this one isn't, but they can be still fitted inside, but under certain conditions. So the garage has to be basically 60-minute fire rated, so plasterboard, which it is, and it has to have a mains wired battery backup smoke alarm in, which is what has been installed. Now, in most properties we have to install that alarm. In this property, the customer is an electrician, so they fitted the smoke alarm to our specification to save on cost, which is fine. If you are looking to have one of these systems fitted and you don't want us to do the alarms, then that's fine. We can just provide the specification. You can get your local electrician to do it if you want. Otherwise, we can do it as part of the project. The biggest cost implication to this is usually the fact that full smoke alarm system has to be installed within the property. It's unbelievable how many properties only have maybe a little battery one at the top of the stairs, and that's it. So the PAS document states that smoke alarms need to be fitted to a grade 2 LD2 level, which is basically a smoke alarm in the kitchen, the exit routes, the room that you inhabit the most, which is usually the living room, the upstairs landing, the loft if it's got electrical equipment up there, and also at the point where the battery is. If the battery's outside, then it doesn't need one on the outside, obviously. But if it's in the garage like this, then it does, and that's why just above the garage door here there is a smoke alarm fitted, and they're all interlinked. So if this one goes off because there's a problem with the battery, then it'll set it all off and the family will be able to get out. Now, this hasn't been brought in because these batteries are instantly combusting. I wouldn't be leaning on this if that was the case, but the problem is if you have a fire, say in this consumer unit, an appliance, the whole Grenfell thing, that was all caused by a white good fire. If any of that happens and that fire reaches the battery, this battery within seconds will instantly make that fire worse. And so what we want to do is we want to make sure that you are well out of that property well before that happens. And that's why these smoke alarms are, in our view, so important to get, because you're not spending a couple of £100 with something like this, you're spending thousands. And at the cost of a couple of £100 to get a new system installed in your property, it seems like a no-brainer to protect the family, regardless as to if you're getting a system like this. With smoke alarms, now that we're using a lot more chargers and a lot more battery products in our houses, it has opened our eyes to the threat of these house fires. Now, I don't want this to be morbid and downbeat, but I think it's a really important thing that we all look at and we all start to take seriously when looking at doing a major project like this, because like I said, the cost of doing it is pennies compared to the cost of installing one of these. And if we can do it all at the same time, there's VAT savings, there's savings with us already being here to do this. Let's get your home upgraded to a level that is safe for the family, and yeah, let's protect the family whilst also reducing those energy bills. So that's just something I wanted to touch on. There's a lot more in the PAS document than just that, but they're the main parts that we pull out and that we abide by. But yeah, that's the PAS document in a bit of a nutshell. Okay, so one of the common questions we get, and it's a fair question, is how much does all this cost? It's okay showing us all this stuff, but if I want a system like this, how much is it going to cost? First, the disclaimers. Obviously, this is priced based on this property. It's priced on the product costings at the time. This kit moves on so much, and the costings do change, and any offers that the manufacturers are giving at the time. So the costs are always different across all different properties, but this will hopefully act as a bit of a guide for you to know how much you might be looking to spend on something like this. So this is what we've installed. This is how long it's taken, and this is the total cost for the system. So hopefully that helps to budget for a system like this, or you might want a bigger system or a smaller system. We can do basically anything. We can have a look at what your requirements are, your future plans, and look to get you a system that fits your budget, fits your property, and fits your expectations. So yeah, hopefully that helps. There we go, another YouTube video all done and dusted. So thank you very much for watching, and thank you very much for commenting if you do, with any questions, anything you like, anything you dislike. I'll take as much feedback as possible from everybody to see what you want to see in these systems, but also some questions. I can't cover everything in this video, I can't think of everything in this video, but the more comments and questions we get, the more I can add into these videos in the future. So thanks very much for watching. If you fancy a system like this, then we're open for inquiries. Just follow the links below to inquire, and we'll get that ball rolling to get you a system like this or another product that we sell. So thanks very much for watching. Please like, subscribe and all that, and we'll see you on the next video.